Moving on to the next tab, span loads. The user has the option to automatically include the beam weight based on the beam size that we selected. Additionally, the user has the option to automatically include the slab self-weight. Let's enable both of these options by checking the adjacent boxes. Once you enable the option for including the slab weight, you will get to input the slab trip width. In our example, the beams are at 8 feet on center, hence we will use a trip width of 8 feet on center. The slab weight is automatically calculated based on the average slab thickness as well as the concrete density as defined by the user under the General tab, which in this example was defined as 145 PCF. It is important to note that InnerCalc performs the calculations in real time. As soon as you make a change, InnerCalc auto-calculates and instantaneously displays the results. We already applied the weight of the beam as well as the weight of the slab with 8-foot trip, and the results are already updated on the right-hand side for both composite and pre-composite capacities. InnerCalc allows the user to apply various types of loads such as uniform loads, trapezoidal loads, or concentrated loads, for example. Let's start by applying a full-length uniform load. For the purpose of our example, we want to design the beam for 40 PSF dead and 40 PSF live. Then we check this box next to the tributary width and apply a trip width of 8 feet. Since the construction is unshored, then we have to determine the load application. InnerCalc offers 3 options. Applied to pre-composite section and removed before curing. This means this load will apply to the beam in its pre-composite state, aka just relying on the steel beam capacity by itself. The load in this category is considered to be temporary load, such as construction loads, because once the concrete cures and the final composite state is achieved, this load is removed. The second option is applied to pre-composite section and remains after curing. This is a load that will apply to both pre-composite as well as post-composite states. This load demand will be checked against the pre-composite steel section capacity, aka just the bare steel alone. Then this demand again will be checked against the post-composite beam capacity. The last option we have is applied to post-composite section only. This means this load will apply to the beam in its post-composite state only after it achieves the composite action. The user can use these designations however they see fit. The dead and live loads we just entered are the final loads. This means that these are the loads that I want to apply to the beam after it achieves the composite action. Hence, I will classify these loads as applied to post-composite section only. Next, let's add another load set for construction loads. So we will click on the Add Load button, then select the full-length uniform load. Let's apply 20 dead and 20 live, and we are still using the same trip width of 8 feet. This is a temporary construction load that will be removed before curing and will not be present after the construction is complete. Hence, we will classify this load as applied to pre-composite section and removed before curing. Lastly, it is critical to note that because we selected the options to automatically include the weight of the beam as well as the self-weight of slab, those loads are considered in both cases. This is a logical assumption because the self-weight is always present. If a user wants to add additional load cases, they can follow the same simple steps. Lastly, The table below summarizes all of the load case entries, and you can cycle through them in case you need to modify, copy, or delete any of the loads. If you like to learn more or have any questions, you can visit our website, innercalc.com, or send us an email at support@innercalc.com. Thank you for watching.